Okay, we're going to work on the problems on the lead code problem. So this gonna be this problem. So this is a linked list problem which I have working with my friends today, like this morning. So I just want to continue working on that and try to understand. So let's go through the problem here. Okay, this is a problem, and I just find out the lead code allow us to collaborate here. So if you see here, if you click on your profile, up, let me check. Okay, yeah, you see that like you can invite other people to collaborate and working together at the same uh typing here, right? Collaborate. It's like usually what we do, we use what I try to do, I use it for free, like CoderPad, which they allow to use only a few times in a month in one account, and the other one I use is more on Code Sandbox, which sometimes I use that for mock interview with a friends and then study together. We kind of like take turns, right? Like if you use over, then limited. I'm not sure like on CoderPad is around only for three times. I cannot remember, but this lead code is new for me today, so that's what we use it to study with friends this morning. And I'm not sure also about you need to be a premium member here to use, but this good, is another tool for us to collaborate with others and pair and learning, study, pair programming together. So let's go through this problem. Okay, so let's get started. Okay, the add to number. I think I worked on that problem before, like 2022, which I start to learn how to work on algorithm problems, which is new for me. And the linked list is kind of like my weak area I didn't really good at. So let's go through this problem. This one is a medium problem. You are giving two non-empty. Okay, you are giving two non-empty linked list represent two non-negative integer. So that's the key. So they're not gonna be null. It's not gonna be empty, and the number not gonna be non-negative integer. So can be zero and positive integer, and also gonna be only integer and only gonna represent only one uh, single digits. The digits are stored in reverse order, and each of their nodes contain a single digit. Add the two numbers add the two numbers and return sum as a linked list. Okay, so you may assume that two numbers do not contain any leading to zero except the number zero itself. And we go through some of example here. So we have the links one and the links two. So the list one is contain 2, 4, 3. The list two is contain 5, 6, and 4. And the result will be 7, 0, and 8. How is that gonna be? So when we add like 2 and 5, we got 7. And then we add 4 and 10, we got 10. So we add to zero, add zero, right? And then we have one carrying over to the next one. It's kind of like the math problems. So, and then we add 3 and 4, we sum up to 7. And then we have one carrier. So that's we add 0 to number 8. That's why gonna be lead to 708, and then that is gonna be result as the output here. So there are explanation here. It means three. Where is okay? 3, 4, 2 is when we have to reverse order like back, and then 304, and then 465. That's what we return the result of 807. But the result output of the linked list is new list will show 708. Let's go through the next example. Okay, and that also have like a zero and lead to zero. We have a very interesting example at the example 3 here. So the inputs will be, okay, so also you can be the same length. Oh no, different lengths. So it's also possible we need to iterate through either of them with different lengths of the list. That's what we return here. So let's go to some of dry run example. So let me just go ahead to, let's say, I think I'm gonna grab this example. In short, okay, L1 is gonna be 999. And how about L2? L2 will be, what about 99? Okay, that is the different length, 9 and 9. Okay, what is the result? So let's think about, that's why they call reverse order. Like when we're really adding the number in math, right? So we need to be like at that point. So what the result will be, it's 8. We carrying 1 over will be 8 is 9. We also have the 1 carry over. Okay, 9 and 9 we add them to 18, so we have 1 left. So 9 and 9, 18, and we plus 1 is gonna be 9. And this one will be 9 adding 1 carrier will be uh the result will be n 0, right? So, but the result when we return, we need to reverse order back. It's gonna be, okay. The result of output will be 8901. So that is this example, right? Okay, that's it. So what we're gonna do here, my plan. Okay, let's go ahead to talk about that. We concerned about what is input and output. So, uh, input will be to linked list, and output will be uh, sum of two. Okay, that's gonna be new list with sum of list one and list two on the same position, list two. And the constraint talk about the number of nodes in either linked list is going to be between length of 1 to 0. We don't need to worry about the negative number, or it can be 0. Not sure. Yeah, it's 0 can be also. And the length will be, yeah, okay, so that is not going to worry about the null nodes, right? And what's the next one? Let me move in a little bit. Okay, so that's what we concern about. And we move to, okay, so my plan, my plans, like my approach first, what I'm gonna do, I'm gonna have to define new head with we gonna use to maintain with a link list node, with is can be either to be null or let. And then that's what we're going to use to return when we maintain another. But we want to use another node to maintain each iteration while we travel to the list. So we are going to define the current node, which is going to set to head, new head. So our new head will join or the linked list as a result later. Okay, that's what we also have, but I also need to have the carrying variable to maintain each time when we're adding the value and we have 1 carry over to the next position. So I'm gonna define the carry number as set to 0, and that is my initial value, to set and maintain them. But my logic will be iterate. Let's move up a little bit. Iterate through the pivot list Okay, and then we're gonna travel to, we're gonna have another variable which is gonna call sum. So we're gonna set initialize sum. With sum gonna be like adding to the value each time. But first we need to set the sum at the carry. So that's why the sum can maintain each time on iteration of both linked list. So we check if, let me think about, we check if we have list nodes. So we want to iterate to the first list because they both can be different length. So we're gonna say like if list one is not empty, if list one, if while we have list one in the iteration. So what we're gonna do, we're gonna sum add to the val, right? Node val. That's why we can add each value to the sum, and then we're gonna move list one to we move to the next node, right? By like list dot next, list one dot next. That's why we can move to each pointer to each node. Okay, so and also I let's say my logic also will do iterate to the list two as well. We're gonna do the same thing here by adding list two to the value of the sum. Okay, but the concern thing here, we're gonna have to think about how we have the number when adding more than like 9, right? When we get to the 10, is in 2 digits, we cannot add them because we want to have left the carry left over, which is gonna be carrier number. So what we gonna have to do is like we want to find the carry over by like what number we carry over to the next nodes by really redesign of the carry the first value by like that is kind of a math problem. So I'm gonna use like row for up for down like by using sum and divide it by 10. That's why we get the carry over like 1 digit, right? And then next I'm gonna have to assign the sums, which is the carry, to the new node. What I gonna do here, I gonna say like our node dot next, we're gonna assign to the new node, which is gonna be lead node, list node, and we're gonna have to uh, find out what is the sum by using sum, and we want to modulo with tens. That's why we get 0 or 1 or the left. Or to add to sum. That's what we can use modulo. That is the two part is very important here. If we have to deal with sum which is over than 2 digits, I think they have another way, but this is more effective for me. I do need to remember to do that as well. So then what we do next is mean we're gonna travel because we already assigned the next carry the node next, which is the new sum. So what we're gonna do here, we're gonna have to move current node to current node the current node to the node dot next to the next node, right? So gonna be current node dot next. That's it more on our logic here. And at the end, what we're gonna return, we need to return the main part. We're gonna return new head, which is gonna be the new head dot next. Okay, that is already on the plan. To think about time and space, let me see here. So because we need to iterate through the list, both of the list, time will be O of n time to iterate to the list. It means O of n times depend of the length of both, right? So either which one is longest, that's what the time's gonna be, the time complexity gonna be. And space, we also define a new node which is we gonna sum up. So the time will be O of n times of the length of the most longest list like either list one or list two. Okay, let's go jump down to coding now. So I say I'm gonna define a new node, new head, sorry, and we're gonna say list. We have class list. It's gonna be on the top here. Okay, they already define new list. New. We don't forget the keyword new. This is we can define as either or no. I can set to no because we didn't really return the first one. We're gonna return uh new head after maintain and add value here. Dot next. Okay, and at I say gonna define cur node. We're gonna set to new head, and we're gonna have carry. We set to 0, and we can have vowels, while L1 or L2. Also, we need to check if the carry is not 0. We have to say if no, not carry over. The carryover number should not be 0. That's why we can move to is node. That the rest one is the longest. Okay, the carry is not 0. Okay, that's well, and then we have to define another sum, which we point to carry, and then we say if L1 still exists, we're gonna move L1 to L dot next, but we also have to add the value to sum adding to L1 dot vowels. I believe they use wow. Okay. L1. Okay. And we do the same thing with the list two. So let's see here, the list two. Okay, where is the, okay. List two will also add to its value to sum. So we can add its value to the sum. Okay. And what we do next, that is the main part of, we need to reassign the carry. How many carry over to the next node by using, let me think. Okay, I'm gonna use math.for method, which is roll down of the number. So we say sum divided by 10. That's why we can get only one digit to carry over. And then we're gonna say cur node dot next. We're gonna have to be new list node. And then we want to set the values of the sum modulo by 10. That's why we either get like this number to add to the value, only one digit to add to the node. Okay, and then the carrier over will be moved to the next position, next node. Okay, so then we need to move cur node. It's gonna assign to cur node dot next. Okay, so that should be it. So okay, here, so that, yeah, okay, that's the same thing here. I try run here. So let's test if our code is working. Gonna run test, yeah. Okay, that's cool. So that has its run and runtime is 0 millisecond. That's good. And gonna do submit if they are passing all tests. Okay, they accepted. So let's see. That's cool. So we spend runtimes in 2 milliseconds. Oh, that's cool. And we use memory 624, which I'm not really understand that much, but that's a good solution. So that's what I'm gonna end up today. Thank you for watching.